Welcome to Module 17 on radical equations. Make sure you have your notebook out so that you can take good notes today. Remember that it's important to take good notes because you can use your notes on the quizzes and on the final exam. Turn to a new page in your notebook, write Module 17, Radical Equations. We're going to be talking about solving a radical equation that simplifies to a linear equations, and then we're going to do some word problems involving radical equations. Let's first just talk about what is a radical equation. When we solve an equation, we use inverse operations. So something simple like x plus 2 equals 4. If I want to isolate the x, I need to do the inverse of whatever is with the x. So the opposite of a plus is a minus. So we would subtract 2 from each side and find out that x equals 2. A radical equation is just an equation that has the variable inside the square root. We can also use inverse operations to solve these types of equations if we remember that squaring is the opposite of a square root. So I want you to write down this thing that I just put in the box. Squaring is the opposite of a square root, and I'm going to show you why now. If I find the square root of 4, we already know what the square root of 4 is, but I want to show you what happens when we square the square root of 4. Well, when I square the square root of 4, that means the square root of 4 times the square root of 4, which means the square root of 16. And the square root of 16 is 4. I want you to start looking for some patterns here. What if I have the square root of 5 and I square it? The square root of 5 times the square root of 5 is the square root of 25, which is just 5. The square root of 6 squared is the square root of 6 times the square root of 6, which is the square root of 36, which is just 6. Look what's happening. When I square the root, it cancels out both items and you get 4. Square the square root and you get whatever's on the inside of the square root. Square the square root, you get whatever's inside the square root. If I can memorize that pattern, I can skip all these steps. I can also simplify something but I don't know what is inside the square root. I don't know what the square root of x is, but if I square it, that's the square root of x times the square root of x, which is the square root of x squared. The square and the square root cancel out, and so x is isolated. So squaring is the opposite of a square root. So what you're going to be solving today is radical equations, equations that have a radical with a variable on the inside. So I want you to put a new topic, solving a radical equation. Write your first example down. So we've got the square root of y equals -6. Now, if this were like y plus 2 equals -6, you would subtract 2 from each side and you get y equals -8. It's the same idea. You want to get rid of the square root. And we do that by squaring both sides. The square and the square root cancel out, and so y is isolated, and -6 times -6 is positive 36. You pause the video and try this one on your own. All right, you should have noticed that you had the square root of y is equal to 9. You want to get the y isolated. It's inside the square root, so we're going to square both sides. The square and the square root cancel out. 9 squared is 81. Now, you can have other things inside the square root, but whatever is inside the square root has to stay in there. So, for example, on this one, I could not just subtract 11 from each side. The 11 is trapped inside the radical with the w. What I would instead do is square both sides. The square and the square root cancel out. I end up with w plus 11 equals 81. Then we're going to subtract 11 from each side, and so w equals 70. Notice I didn't subtract the w until I had gotten rid of the square root. You pause the video and try this one on your own. You should have noticed that the 3 and the x are both inside the square root, so we're going to square both sides. The square and the square root cancel out. You're left with x plus 3 equals 25. Now this is just a one-step equation. We subtract 3 from each side, and we find out that x is equal to 22. Let's try another one here. I notice that everything that's on the right-hand side is trapped inside the radical. In order to get rid of the radical, I'm going to do the opposite. I'm going to square both sides. The square and the square root cancel out on the right-hand side, but not on the left. 2 squared becomes 4. Notice I am never squaring what's inside the radical. I'm just bringing it down. Now this is a two-step equation that I need to solve. I subtract 16 from both sides. I get negative 12 equal to negative 3w. We're going to divide both sides by negative 3, and so w is equal to 4. You pause the video and try this one on your own. Remember, you get rid of the radical by squaring both sides. See if you can go from there. All right, the square and the square root cancel out, so there's no reason to square the 2u minus 8. We just bring that down. 4 squared is 16. Then you should have seen that this is a two-step equation. You add 8 to both sides, so 2u equals 24. Divide both sides by 2, and so u equals 12. Now, this one's a little different than what we've looked at before. Take a minute, see if you can recognize what's different about this problem compared to what we just did. What you should have noticed is there is a number on the outside of the radical. We want to get rid of that number on the outside of the radical. So for example, if I had 13 plus x equals 6, we would start by subtracting 13 from each side. It's the same idea here. We want to isolate that square root. So we get the square root of u minus 4 equals negative 7. And then we're going to square both sides. Anybody remember why I always put parentheses around my negative? It's because it helps me to remember that a negative times a negative should become a positive here. That should not be a negative 49. The square and the square root cancel each other out. We do not square the u and the 4. We add 4 to each side. So u equals 53. You pause the video and try this one on your own. Remember, if this said negative 3 plus x equals 7, what would you do first there? Well, you should have said that you would add 3 to each side, so we're going to do the same thing here. We want to isolate the square root by adding 3 to each side. So we have the square root of w minus 4 equals 10. We're going to square both sides. The square and the square root cancel out, so there's no reason to square the w minus 4. But there is nothing to cancel on this side. 10 squared is 100. We add 4 to each side, so w equals 104. You pause the video and try this one on your own. Remember, if this said x minus 4 equals 4, think about what your first step would be. Well, your first step on this would be to add 4 to each side. It works the same here. You want to isolate the square root. The minus 4 is on the outside of the radical, so we add 4 to each side. We're left with the square root of v plus 9 equals 8. Now that the radical is isolated, I can square both sides. The square and the square root cancel out. You're left with v plus 9 equals 64. Subtract 9 from each side, so v equals 55. You pause the video and try this one on your own from start to finish. Well, you should have thought about if this equation said x minus 3 equals 5, the first thing you would do would be to add 3 to each side. It works the same here. In order to isolate the radical, I need to add 3 to each side. But instead of having an x, I have the square root of x plus 13 equals 8. Now I can't subtract the 13 because it's inside the radical, so I square both sides. The square and the square root cancel out, leaving me with x plus 13 equals 64. Subtract 13 from each side, and so x equals 51. Now, new topic, radical equations and word problems. I want you to start by writing down your equation, v equals the square root of 32d. And let's see what we're given. This is the formula for the depth of the water and the velocity of the wave. This gives us the depth of 4.3, so we know d equals 4.3. And we're trying to find the velocity. So I'm going to substitute in. When the 32 is right next to the d, that means to multiply. And then let's think about order of operations. Is there a reason to square both sides? Is the variable inside the radical on this one? It is not. Order of operations says to do what's inside the grouping symbol first, and the square root is a grouping symbol. So we do 32 times 4.3, and that gives me the square root of 137.6. Now I just use my calculator to get the square root of that answer. And it says round to the nearest tenth, so that gives me 11.73030264. The tenths place is to the right. We look to the right, the 3 tells me to leave that the same, so that should be 11.7. And this is velocity, and that's feet per second. You pause the video and try this one on your own. You should have started by writing down your formula, and then look for what they gave you. They give you the surface area. The surface area is 415.8. They want to know the radius. So you're replacing S with 415.8. And notice you no longer have a variable on the inside of the radical, so there's no reason to square both sides. We do 415.8 divided by 12.6. That gives me 33, because remember, order of operations says do what's inside the square root first. We find the square root of 33, and that gives me 5.74456267. This says round to the nearest tenth. The 7 is the tenths place. The 4 says to stay the same. So that is 5.7, and the radius is in inches. Now, this one's a little bit different. We still have our same formula we just used, the formula for the surface area. But this time, they give us the radius. The radius is 14.83, and we're trying to find the surface area. So the 14.83 goes here, and that surface area is trapped on the inside of the radical. I can't get rid of the 12.6 because it's trapped inside that grouping symbol. So this is why sometimes on a word problem we need to square both sides. So I'm going to do 14.83 squared, or 14.83 times 14.83, they mean the same. That gives me 219.9289. Remember, the square and the square root cancel out, so that's S divided by 12.6. We want to isolate the x, so we do the opposite of divide, which is multiply. We're multiplying both sides by 12.6. Let's see, it says to round to the nearest tenth, so I get 2771.10, so that's 0.1. The surface area is in centimeters squared, and that's equal to S. You pause the video and try this one on your own. All right, you should have started by writing down your formula. Notice that the 9.8 and the D are the inside of the square root. They're giving you the velocity, and they're asking you to find the depth. So we should put the velocity right here. And then notice, I need the depth, but it's trapped inside the square root, so I square both sides. 5.2 squared becomes 27.04. The square and the square root cancel out, and you're left with 9.8 times D. I'm going to divide both sides by 9.8. 27.04 divided by 9.8 gives me 2.75918367. This says to round to the nearest tenth. The 7 is in the tenths place. We look to the right. The 5 says to round up, so that becomes 2.8, and the depth is in meters. And you're done. This video will be available on Haiku if you need to rewatch, and will be available on each skill for Mod 17 in ALEKS. You should now complete Mod 17 practice problems by selecting Continue My Path. Don't forget to click on the explanation if you need some extra help, and don't forget to take Quiz 17 when you've done all the practice problems from Module 17.